Hi guys, my name is Claire. Welcome to Electricity and Electrical Safety, Milady Chapter 7 for Estheticians. We are going to go right into our learning objectives. We want to explain electricity and electrical safety, outline electrical theory, practice electrical equipment safety, identify electrotherapy modalities, and discuss light energy. As a beauty professional, relying upon a variety of electrical appliances, knowing what electricity and electrical safety devices are and how they work will allow you as a professional to use these tools wisely and safely. So, a basic understanding of electricity will enable you to properly use and care for your equipment and tools. Electricity use impacts our other aspects of our businesses and the environment, such as lighting, temperature, heating tools, the music, all of the things that incorporate into our environment are more than likely powered by electricity in some capacity. So, because of that, this concept impacts all of the services in a beauty professional's wheelhouse and what we offer to our clients. There are advanced electrical and light therapy machines or devices that require a foundational understanding of electrical theory to be operated and safely and effectively used. So we're not going to talk too much about the individual modalities. We'll get into it, but there are advanced topics and treatments where we will delve into those electrotherapy modalities. So for now, it's really about electricity and safety. So you decided to enter the field because you love beauty, you love wellness, and all of the services that you can offer to clients. You have things from as high as hairstyling and hair coloring to facials and massages, nails, waxing, eyelash extension application. All of these services would be very difficult to offer without electricity. So, as you study this chapter, I want you to learn how important it is for you as a beauty professional to be comfortable understanding the electrical currents coming in and out of your beauty environment. So, we've got a little grid here showing kind of the flow of electricity. You have electric currents, conductors, non-conductors, and complete electric circuit, which is what we're seeing here, complete electric circuit. Electricity does not occupy space or have mass. Mass is considered weight. You've probably all learned this in middle school science, but again, electricity does not occupy physical space or have any weight or mass to it. So it is not matter. And because of that, because it's not matter, what is it? Well, electricity is the movement of electrons from one atom to another along a conductor. Electricity is a form of energy that, when in motion, exhibits magnetic, chemical, or thermal effects. An electric current is the flow of electricity along a conductor. So, a conductor, we can deduce just by understanding that the current runs through it, is something that is going to allow electricity to move through it. So, all materials can be classified as conductors or non conductors, depending on the ease of which an electric current can be transmitted through it. So a conductor, something that's going to easily allow electricity to be transmitted through it, to make an electric current, to make the circuit, is any material that conducts electricity. Most metals are good conductors. That means that electricity will pass through the metal easily. Copper is a particularly good conductor and is used in electrical wiring and electric motors. Pure distilled water is a poor conductor, but because the ions usually found in ordinary water, such as tap water or river water or even lake water, make a much better conductor. This will explain why you should not swim in the lake during an electrical storm. So distilled water, where all of the atoms and ions and all of the things have been pulled from it, makes for a poor conductor. Tap water, river water, lake water makes for good conductors because of those things that are not pulled allow that electricity current to flow through it. You then have non-conductors. These are also known as insulators. More than likely, anything that you read is going to have insulator, not non-conductor, but the two words can be used interchangeably. So an insulator is a material that does not transmit electricity. I want you to think rubber, silk, wood, glass, and cement. All of these are good insulators, meaning they are blocking the flow of electricity. Electric wires are composed of twisted metal threads, which are the conductor, and then covered with a rubber or a plastic coating, the non-conductor or insulator. And then a complete electrical circuit is the path that the negative and positive electric currents take from generating source. So it takes it from the generating source, moves it through the conductors, those wires, protected by a non-conductor or an insulator, to the source that is being powered by the electrical current. So that is an electric circuit. You need a conductor, you need non-conductors to make it safe, and you need power to be generated from one and transferred through those lines to power whatever device you're trying to use. So types of electric currents. You have direct current, which is DC, and alternating current, which is AC. The differences between the two are on the screen, but while you're looking at those, I just want to talk a little bit about direct current and alternating current. So abbreviated as DC, direct current, think direct, is a consistent, even flowing current that travels in one direction. And it's only produced by chemical means, meaning flashlights, cell phones, cordless tools use the direct current, which is produced by batteries. So the battery dies, the current no longer is produced, the chemical process doesn't happen, no power to power the device. An inverter is an apparatus that changes direct current to alternating current, and inverters usually have a plug and or cord. They allow you to use the appliance outside of your salon, spa, barbershop, or home that would normally have to be plugged into the wall. The phone charger in a car is an example of an inverter. And then you have alternating current. This is abbreviated as AC. Alternating current is a more rapid and interrupted current that's flowing first in one direction and then back in the opposite direction. It is produced by mechanical means and changes directions over 60 times per second. Things like corded hair dryers, curling irons, electric files, and table lamps that plug into a wall outlet use alternating current. This requires a rectifier, which is an apparatus that changes alternating current to direct current. Cordless electric clippers and phone chargers use a rectifier to change the AC from an outlet wall to DC to recharge the batteries. So you're coming in contact with both AC and DC currents pretty consistently throughout life as we use electricity with most things. So it's good to know the difference between a direct current that's going to be a consistent even flow in one direction versus an alternating current, which is going to be a rapid and interrupted flow that's traveling in one direction first and then back in the other using a rectifier. So here are some electrical measurements that you want to be familiar with. I want to give you a moment to screenshot those, and then we will take a minute to define each one of them just a little bit. It is abbreviated as V and also known as voltage. It's the unit that measures the pressure of force that pushes electric current forward through a conductor. You have ampere, A-M-P-E-R-E, and this is abbreviated as A, also known as amp. It is the unit that measures the strength of an electrical current. You have milliampere, which is abbreviated as M capital A, and is 1/1000 of an ampere. This current is used for facial and scalp treatments and is measured in milliamperes. You have ohm, OHM, abbreviated as O, and it is the unit that measures the resistance of an electrical current. You have watt, abbreviated as W. It is the unit that measures how much electric energy is being used in 1 second. And then kilowatt, abbreviated as kW, is 1,000 watts. The electricity in your house is measured in kilowatts per hour. So let's check in for a second. Define the two types of electric current. Remember, it was DC and AC. I'm going to give you just a second here to write out what is DC and what is AC, and then the differences between the two. Okay, for DC, you should have direct current, and it is a constant, even flowing current that travels in one direction. It's produced by chemical means. You then have AC, or alternating current, which is a rapid and interrupted current flowing first in one direction and then in the opposite direction. It is produced by mechanical means. Practical electrical equipment safety. So practice electrical equipment safety. I don't know where I got practical from, but practice electrical equipment safety. So safety devices are two things that you've probably seen in your home: a fuse and a circuit breaker. A fuse prevents excessive current from passing through a circuit, while a circuit breaker is a switch that automatically interrupts or shuts off an electrical circuit at the first indication of an overload. In your environment, you should have both a fuse box and an circuit breaker. So in your home, I want you to go to your circuit breaker and realize how it's connected to different parts and different areas of your home. And then same for a fuse box. There's a fuse box in your car. If you've never had to change a fuse, you're probably very fortunate. But if you've ever had an older car and a fuse went out, so you weren't able to use something in your car, you took it to the car people and they were able to quickly replace that fuse. Well, that's just little things that electricity uses for our safety as well as for the continued effect of using electricity. So you want to be aware of these two things and where they're located for each piece of equipment and in your home or in your salon. Some more electrical equipment safety items are going to be grounding, ground fault interrupters or GFIs, and underwriters laboratories or UL. These are things that are available in your location as far as your business, but I have the most experience with them in a home. For example, a GFI or a ground fault interrupter is designed to protect from electrical shock by interrupting a household current when there's a leak in the circuit. So GFIs are required by the electrical code for receptacles in bathrooms, kitchen, and outside receptacles. Now the city regulates this information, and I say now, but for a while they have. But for example, in a new home build, all outlets have to be equipped with GFIs. And those are the little details that keep us safe in our homes and in our businesses when dealing with electricity. ULs, or Underwriters Laboratories, certifies the safety of electrical appliances. These are your tools and your implements. And if you are buying any professional device, they should be UL certified. Guidelines for the safe use of electrical equipment. Make sure that all electrical appliances you use are UL certified. Read all the instructions carefully and thoroughly. Understand them. Always register electrical appliances with the manufacturer. Disconnect all appliances when not in use, or unplug the plug to the cord to disconnect. Disconnect all electrical appliances prior to cleaning them. Never tamper with appliances. Always inspect your equipment regularly. Keep all wires, plugs, and electrical equipment in good repair. And use one plug in each outlet. Overloading may cause the circuit breaker to pop. If you're noticing the circuit breaker is popping consistently, try spreading out your equipment. If you're still having the problem, the landlord of your building needs to have an electrician come out and properly replace and update the electrical wiring because it's not working properly. So guidelines for the safe use of electrical equipment continued. Avoiding contact for both you and your client with water and metal surfaces so that you don't electrocute yourself or them. Keep your electrical cords off the floor as much as possible, especially in areas where walking is paramount. Do not leave your client unattended while the client is connected to an electrical device. Do not attempt to clean around electrical outlets while equipment is plugged in. Do not touch two metal objects at the same time if either is connected. Do not step on or place objects on electrical cords. Do not allow electrical cords to become twisted. And do not enter a 3-prong plug to fit into a 2-prong outlet. That one's kind of self-explanatory. Lastly, do not attempt to repair electrical appliances. Please call a professional. If you see sparks or any type of catch when you are plugging or unplugging a device, do not use the appliance or outlet until it has been properly inspected by an electrician. Verify regularly that fire extinguishers are appropriate for electrical fires and are not expired. And remove lint from clothes dryers before each load to reduce the chance of a fire. So a quick hazard sweep. I'm going to leave you for a few minutes and I want you to do a hazard sweep of the environment you're standing in right now. Just make a quick list of all the electrical devices available and see if you can find any that say GFI or UI. Quick break. I'm going to give you, let's say 2 minutes. So there'll be a 2-minute little quiet space, but I want you to do the activity just so that you can locate those things on some of the common devices wherever you are right now. And go. And we are back. So, how was your hazard sweep? Did you locate any GFIs or UL products? Let's talk about an emergency and what to do in the event of one. So, if you were likely shocked or if an appliance fell into water, this is kind of some things that you can do. So, low voltage shocks are rarely critical, but they can be quite painful and dangerous to some individuals. If you receive a light shocking sensation when using, turning on or off, or plugging or unplugging in any electrical appliance, do the following. Stop using the appliance immediately, turn it off, or if it's on, leave it on and immediately reach out to an electrician. If you can safely unplug it from the wall or turn off the circuit breaker to that outlet, me personally, I would go straight to turning off the circuit breaker. I'm not going to touch that appliance anymore. Replace the appliance or have it repaired by an authorized repair representative. And if similar issues occur with other appliances in the same outlet, discontinue use of the outlet and have it approved by a certified electrician. If you drop an electrical appliance in water, this is going to be kind of unlikely in your beauty business. There's no reason you should have sets of water sitting around, but if you were to have that happen, if the outlet is GFI protected, it'll kill the circuit immediately and you will unplug the appliance from the wall, and then you will have, you'll have to dispose of that appliance. If the outlet is not GFI protected, go to the breaker box and flip the circuit off. If you're unsure or unaware of what circuit you have, then turn off all circuits. Never use an appliance that has been dropped in water again. So once the appliance has been dropped in water, dispose of it properly and make sure that no one else has an opportunity to use it either. Let's talk about when to seek medical attention after dealing with a burn or any type of electrical shock. If you are pregnant or currently lactating, I would speak to my physician immediately after an electrical shock. If you have burns on the skin that are visible to you, particularly those that are open or aren't healing well, and if you are not current on your tetanus immunizations, which are given every 5 years to adults. Honestly, when in doubt, call 911, have someone come out, get checked out. There's no, reason to suffer with the advancement of medical care. Get someone out there to check on you and your client if this does happen to either one of you. So, electrotherapy modalities. So, first, I want to define electrotherapy. The use of electrical currents to treat the skin is commonly referred to as electrotherapy. Currents used in electrical, facial, and scalp treatments are called modalities, and each modality produces a different effect on the skin. An electrode, also known as a probe, is an applicator for directing electric current from the electrotherapy device directly to the client's skin. It is usually made up of carbon, glass, or metal, and each modality requires 2 electrodes, one negative and one positive. This will allow the electricity to be conducted and flow through the body. The only exception to this rule is Tesla high-frequency current, which uses a single electrode. But because the polarity in that electrode go back and forth so often per second, you won't need to, ground one with the other, negative with positive. So I mentioned polarity, so let's go a little bit into that. Polarity refers to the poles of the electric current. Either can be positive or negative. Both must coexist. You have to have a negative, you have to have a positive, except for the high frequency. The electrodes on many electrical devices have one negatively charged pole and one positively charged pole. The positive electrode is called an anode and is usually red, marked with a P or a plus sign. And the negative electrode is called a cathode and is usually black and marked with an N or a minus sign. The negatively charged electrons from the cathode flow to the positively charged anode. If the electrodes are not marked, ask your instructor, manager, or supervisor to help you determine the positive or negative. If you have a device and the electrodes are not marked, get another device. Your instructor is not going to be any more knowledgeable on it. That's a manufacturer defect that I would not work with. So let's talk about the modalities themselves, right? The modalities that use electrical current. We already mentioned Tesla high frequency, but if you're at the point in your class where we're talking about electrical safety, you've probably already been introduced to another one, which is galvanic current. Galvanic current is a consistent and direct current, which is having a positive and a negative pole that produces chemical changes when it passes through the tissues and fluid of the body. So because our body is made up of water, and remember, water is a good conductor, galvanic current uses the water in our body to pass through the tissue and create a chemical change. 2 different chemical reactions are possible with galvanic, and it depends on the polarity, remember polarity, negative or positive, that we're actually using. So the active electrode is the electrode used on the treatment area. So the active electrode in the case of galvanic is the one that we are working across the client's skin. That can be negative or positive depending on what it is we're trying to do. While the inactive electrode, this is the positive, this is the opposite polarity from the active electrode, and the effects produced by the positive pole are the exact opposite produced by the negative. So galvanic current is used to infuse water-soluble product into unbroken skin, and the scientific term for this process is called phoresis. There are 3 types of chemical reactions that can take place: anaphoresis, cataphoresis, iontophoresis. You then have deincrustation, which is a form of anaphoresis. So let's talk about iontophoresis. This is the product of infusing water-soluble products into the skin with the use of electrical current, such as the use of positive and negative poles of the galvanic machine. You then have cataphoresis, which infuses an acidic, positive product into deeper tissues using galvanic current from the positive pole toward the negative pole. And then you have anaphoresis, which infuses an alkaline or a negative product into the tissue from the negative pole towards the positive pole. Deincrustation, which is a form of anaphoresis, meaning we're using a negative or an alkaline product, is using a product that is used to soften and emulsify greasy deposits like oil, blackhead in the hair follicle, so that we can liquefy that sebum and easily push it out of the follicle. Deincrustation is frequently used to treat acne, milia, pimples, comedones, blackheads, whiteheads, any acne type lesion that you would think. you would use the de-encrustation, which is a form of anaphoresis, to soften and emulsify the sebum so that you can push it out. So here is a quick breakdown of the benefits of the modalities. I want you to take a screenshot. I'll wait. We are still waiting. And you should have your screenshot. We're going to go to the next one. Microcurrent. So another electrical function that you can use is microcurrent. It's an extremely low level of electricity that mirrors the body's natural electrical impulses. Microcurrent can be used for iontophoresis, which, let's go back real quick. Iontophoresis is the process of infusing water-soluble products into the skin. So microcurrent can be used to infuse water-soluble products into the skin. It can also be used for firming, toning, and soothing the skin. It can also help heal inflamed tissues, such as acne. Newer microcurrent devices have negative and positive polarities in one probe. So there are no longer two probes in more up-to-date microcurrent devices. This allows the client to relax rather than having to hold one probe during the treatment or service. Microcurrent does not travel through the entire body, and it only serves the specific area being treated. Microcurrent can be effective in the following ways. It improves blood and lymph circulation. It improves acidic and alkaline reactions. It opens and closes hair follicles and pores. Increases muscle tone. Restores elasticity, reduces redness and inflammation, minimizes healing time for acne lesions, improves the natural protective barrier of the skin, and improves cell metabolism. So when microcurrent is used during anti-aging treatments, it may give your client a softer, firmer, and more hydrated appearance. But it's not just for aging. You can use microcurrent, which we'll talk about in our advanced modalities, in a lot of different ways. So it's a great upgrade for pretty much any client. Acne clients, anti-aging clients, clients that are looking to, lighten pigmentation issues because of the increased metabolism. Good for people who want to increase muscle tone in the jawline, in the chin, all the facial area to get that stronger jawline. The benefits are really pretty astounding for such a single device, right? Using this modality, microcurrent can be beneficial to multiple skin types and conditions. Then we have Tesla high frequency, also known as violet ray. It is a thermal or heat producing current with a high rate of oscillation or vibration that is commonly used for scalp and face treatments. I have used it in my hair, and I do honestly say that it is really, really great for getting into the scalp, into the skin, stimulating that blood circulation, and allowing the product to absorb better so that you get better benefits from it. The benefits of Tesla high current are stimulates blood circulation, increases elimination and absorption, increases skin metabolism, improves germicidal action, and relieves congestion. So just like microcurrent, many benefits from one device. As you learn more about specific treatments, you'll become familiar with the contraindications, which is referring to stop signs, right? Contraindications are things that make it unsafe to receive electrical modalities. When we do advanced topics and treatments, we're going to talk about those contraindications for all electrical modalities. But just know that contraindications for basic facial are going to basically be a little upgraded for the advanced modalities like electrical currents. So let's check in again. Briefly describe 3 electrical modalities used in beauty and wellness services. I'm going to give you a moment to list the top 3, and then once you're done with this theory, I want you to do a little bit of research on all 3 and determine, based on the type of esthetician you are going to be and what you're going to work with and treat, which of these 3 modalities, if not all 3, are going to be paramount to your business. All right, everyone should have their answers now, and the three are galvanic current, microcurrent, and Tesla high frequency. Energy. The electromagnetic, don't know why I'm struggling with that today. The electromagnetic spectrum, also known as electromagnetic spectrum of radiation, is the name given to all forms of energy. In this case, or in any case, really, radiation. The forms of energy in the electromagnetic spectrum are radio waves, used by radios and televisions, and then microwaves, used by microwave ovens. Light waves, used by infrared light, visible light, and ultraviolet light, used for light therapy sessions. And then you have X-rays, used by physicians and dentists, and gamma rays, used for nuclear power plants. Energy moves through space in these waves. These waves are similar to the waves caused when a stone is dropped into the surface of water. Each type of energy has its very own wavelength, and that is the distance between successive peaks of electromagnetic waves. A waveform is the measurement of the distance between two wavelengths. So some wavelengths are long and some are short. Long wavelengths have a low frequency, meaning that the number of waves is less frequent, so there's fewer waves within a waveform pattern, versus short wavelengths have a higher frequency because of the number of waves tend to be more frequently, so more waves within a waveform pattern. Long wavelengths compared with short wavelengths are going to have things like long wavelengths have a lower frequency, deeper penetration, and less energy, versus shorter wavelengths with higher frequency, less penetration, more energy. Visible spectrum of light. So visible light is the part of the electromagnetic spectrum that can be seen. This is what we see each day and night. Although they are referred to as light, infrared light and ultraviolet light are not really light. What they are, infrared and ultraviolet, are forms of electromagnetic energy. They are invisible because their wavelengths are beyond the visible spectrum of light. So there's a spectrum of light which we can see, and ultraviolet and infrared waves are beyond that spectrum, and that's why we can't see them. So even though they are still light, it is non-visible light, so we can't see it with the naked eye. Invisible light is light at either end of the spectrum, so before it, at the end of it, but it's light that we can't see ultimately. The types of ultraviolet lights are UVA, UVB, and UVC. Ultraviolet A, or UVA, is light has the longest wavelength of the UV light spectrum and penetrates directly into the dermis of the skin. Remember, dermis is the true skin, live skin. This can damage the collagen and elastin. UVA light is the light that is often used in tanning beds. I want you to think of UVA lights as aging lights. UVA lights penetrate into the dermis, damage collagen and elastin, and collagen and elastin is what keep us looking young and youthful. You then have UVB, or ultraviolet B light. These are often called burning light because it's associated with the sunburn effect. So excessive use of both UVA and UVB light can cause skin cancers. UVA tend to age the skin because of the destroying of collagen and elastin, and UVB, or burning rays, are typically associated with sunburns because they burn the tissue in the skin, creating the wounds that we know of as sunburns. You then have ultraviolet C, and then ultraviolet C is light blocked by the ozone. So as our ozone is slowly destroyed, more ultraviolet C light is able to penetrate through, which is not a good thing. If the Earth loses the protective layer of the ozone, life as we know it would not exist. Ultraviolet C is effective at killing bacteria, viruses, mold, and other pathogens. And even though that sounds great, we are essentially accustomed to living with bacteria because there's good and bad bacteria, viruses, mold, and other pathogens. So the destruction of the ozone layer that is currently blocking ultraviolet C rays is not beneficial for life on Earth. We need that ozone to protect us from UVC. So UVA, aging, UVB, burning, and UVC blocked by the ozone layer and is effective at killing bacteria, viruses, mold, and other pathogens. So a little more into infrared light. Infrared light has longer wavelengths, penetrates more deeply, and has less energy. It produces more heat than visible light, and infrared light makes up about 60% of natural sunlight. Infrared lamps are used mainly during hair treatments, processing hair color. They're also used in spas and sauna for relaxation and for warming up muscles. Infrared light has been used to diminish signs of aging, such as wrinkles, and to induce wound healing and increase circulation. So, in a spa environment, if obviously you're not a cosmetologist, so you're not doing hair or processing color, using infrared light, the actual red setting, is going to help with wound healing, increasing circulation, and aiding in relaxation and warming up the muscles. Harnessing that light energy. So you have catalyst and light therapy. Catalysts are substances that speed up chemical reactions. Some catalysts use heat as energy sources, while others use light. Whatever the energy source, catalyst absorbs the energy like a battery, and at the appropriate time passes that energy to the inhibitor, and the reaction begins. Versus light therapy, which is also known as phototherapy, is the application of light rays to the skin for treatment of wrinkles, capillaries, or pigmentation, or even hair removal. These are going to come in the form of laser and light therapy devices, and they have been used for decades. I know in the state of Texas, where we are, you have to have a laser certification or license to actually be able to perform these type of light therapy treatments. So if that's something you're interested in, I would look into that. So we're going to stop and summarize here. As many of the devices and pieces of equipment we use in beauty are electrical, it's important to have a general understanding of the basics of electricity. We talked about the measurements of electricity. We talked about safety. We talked about flow and direction. We talked about devices that we can use in order to create a chemical change in the body with electrotherapy. We cannot perform various skincare services safely and effectively without understanding the different electrical processes and currents that we're using, and that the two types of electrical currents are direct and alternating, so DC and AC. To summarize and review, to finish off this lesson, devices used for electrical safety will include things like fuses, circuit breakers, and ground fault interrupters, GFIs. We did an activity that allowed you to take a look around your current environment and locate the GFI outlets as well as UL products within the home. 3 electrical modalities are used in beauty and wellness services to date, and that's galvanic, microcurrent, and Tesla high frequency. We also talked about expanding more on these when we get to advanced topics and treatments and how you're using them, as well as contraindications. So light is the last subject we touched on, which was visible versus invisible light, and then the ultraviolet rays, UVA, UVB, and UVC. We talked about the differences in those rays and how some are used in the treatment and therapeutic aspects, and some are blocked by the ozone that actually keep us safe. So there is a lot of little technical information within the chapter. I do encourage you to explore a little bit more. There is a case study. We're going to skip over the case study for the sake of this video, and that is it. If you have any questions or concern about the electricity and any electrotherapies, please tune in to the advanced topics and treatments. I believe it's chapter 13, and that is all for me. I'll see you in the next one.